So we're going to look at the first of our rules. It's going to make life a little bit easier for us. And it's called the chain rule. Formally, that's the rule. If you're differentiating u, now u is just some function of x. So some function of x to the power of n, then it's nu to the n minus 1. That's what we saw before. Bring down the power and so on. But you multiply it by the derivative of u. Huh? I find that very confusing. So I think of it this way. Anarchy. Bring down the power. Okay? So, bring down the power, lower the power, diff the inside. So that's anarchy, because you want to bring them down, lower them, so you chuck them on the floor, because once you brought them down, and then you want to put the boot in, so basically you want to kick their insides, don't you? So, we diff the inside. That's it. That's the chain rule. So, how do we do it? Here's that question the other day where I said, at this stage we're going to have to expand out in order to do it. Well, no, we don't. Just with a little bit of anarchy, we can solve this. Bring down the power. So the 2 comes to the front. Lower the power. So the power of 2 becomes the power of 1. We've lowered it. But then we put the boot in. We diff the inside. So whatever's inside the parentheses, we differentiate. Differentiate 2x plus 1, you get 2. And tidying that up, we get 4 outside of 2x plus 1, which you'll recall is the same answer we got the other day. The other day it wasn't factorised, we had 8x plus 4, but it is the same answer. Okay. Why do I prefer it this way? Because you say it as you're doing it. What you're actually saying is what you're doing. 3x minus 4 to the power of 7, I don't have to expand this whole thing out, which would take some time. I can now go, okay, anarchy. Bring down the power, 7 goes to the front. Lower the power, 7 becomes 6. Diff the inside. Okay, differentiate 3x minus 4, I get 3. 7 3s are 21. There's my derivative. Let's try another one. X squared minus 10 cubed. Bring down the power, 3. Lower the power, 3 becomes 2. Diff the inside. Differentiate x squared minus 10, we get 2x. Tidy it up, 3 times 2x, 6x. Try this one. Now there's a 5 already out the front, so when we bring down the power, we go 6 times 5. So bring down the power, 30. Lower the power, 6 becomes 5. Diff the inside. Differentiate 4 minus 2x, I get minus 2. Tidy that up, negative 60 outside of 4 minus 2x to the power of 5. We're basically using this idea. Chain rule, also known as implicit differentiation, also known as rates of change, goes under all sorts of names, but it's all the one idea of where we're saying, hey, a derivative is a rate is a fraction. So if I want to find the derivative of y with respect to x, I can find it with respect to something else, in this case I've said t, and then multiply it by the t dx, because effectively, if you think of it like a fraction, the t's cancel and I still get the y dx. So that's really useful when you have something like this. Remember parametrics. So if I've got x equals 4t and y equals 2t squared, I don't have to recombine these to find out what the actual equation is. I can do it using this idea. I'll differentiate x with respect to t, so differentiate 4t with respect to t, I get 4. Then the y, I'll differentiate the y with respect to t. So 2t squared, differentiate that, 4t. Combine them, so dy dx, well that'll be dy to t times the t dx. So that's the same as saying 4t times a quarter, and it's simply t. So it's still in parametric form, but there's our derivative. It happens to be t. Now, if I wanted to make it in terms of x, I could go back to the x equals 4t. I could rewrite that as t equals x over 4, and then that would be my derivative. Dy dx would be x over 4. So if I wanted to use the x values, I could. All right, let's play with 9e.